So hi guys, we are going to do derivation. The question is conversion of galvanometer into voltmeter 0 to V voltage. Okay, at first you have to know the definition of what galvanometer. So we have done before the introduction of emitter. In that we have introduced as introduction. You should write the introduction and all the parts. It's similar with that emitter, but certain difference. Okay, here comes voltmeter. Voltmeter is an instrument. Okay, voltmeter is also an instrument which is used to measure the potential difference. Okay, here emitter is used to measure current, but voltmeter is used to measure voltmeter is used to measure voltmeter is used to measure potential difference, that is voltage and EMF, okay, of the circuit. So after that, emitter it is a low resistance device. So emitter is a low resistance device, but voltmeter is in reciprocal or conversely relation with the emitter. So it has low resistance, but voltmeter is a high resistance device. Okay, and ideally infinite. In ideal case it is also infinite, but emitter has ideally zero resistance. It has ideally infinite resistance. Okay, so it should be connected in parallel to measure the current, but in the case of voltmeter should be connected in series. Voltmeter should be connected, so it should be connected in series to measure potential difference, that is voltage and EMF. Okay, let's start the derivation. So at first we have to write language. I can write language easily by understanding the figure. So let's draw a figure that looks like, okay, that's the galvanometer and that's the shunt that is connected in series. So then is the high resistance resistor. Okay, and then that the IC current it passes through galvanometer that all is galvanometer, and it is also voltmeter. Galvanometer, okay, that is galvanometer and that is voltmeter. So we have already known that voltage is equal to current into multiplied by resistance. Okay, so here in terms of voltage it's equal to current into resistance, it's equal to here the total current is Ig which passes through, and the two resistance are Galvanometer resistance plus that high resistance shunt resistance. Okay, then the voltage across all of those will be Igg addition by Ig Rs, and then okay, we have done language to convert a galvanometer into voltmeter. Okay, that you have to change. We have to connect as you have to remember small resistance in terms of converting galvanometer into ammeter low resistance low resistance, small resistance. Okay, small resistance called shunt be connected in parallel. Okay, in terms of galvanometer converting into voltmeter. Okay, let's note voltmeter. In case of voltmeter you have to connect high resistance, very high resistance in series. Very high resistance means what is the term is given is Rs. Okay, we have given the term high resistance is equal to Rs. That is R is resistance and S is high resistance. Okay, shunt. Okay, to convert a galvanometer into voltmeter we have to connect what here high resistance, very high resistance. Okay, resistance called Rs in series to galvanometer coil as shown in the figure. Okay, after that the language will be if Ig be the current that causes. I have to tell you, remember one thing in terms of galvanometer. In terms of galvanometer converting to ammeter, we have to remember galvanometer causes full scale deflection. Okay, full scale deflection, and let G has the resistance of galvanometer is G resistance. You can write that in your own language. Then Rs be the resistance of what? High resistance device, very high resistance device. Okay, and then we know that. Okay. Now, voltage is equal to I R. Okay, and then here in terms of current is Ig's passage, but there are two resistance connected in series. So resistance of galvanometer plus resistance of very high resistance device. Okay, and then V equals IgG addition by IgRs, and then IgRs equals, that goes in the opposite side and the sign changes to subtraction IgG, and then you can find the resistance of that high resistance device, that is okay. That is the required equation. That is the required equation. So you can write the language like we have written in our previous derivation. Thus, by connecting suitable value of shunt, and shunt is value of series resistance or high resistance device RS in series to the galvanometer coil, we can convert galvanometer into voltmeter. Okay, that's all for today. We're going to talk about the question derivation action SSB 2065. The question is, a galvanometer can bear maximum current of 25 milliampere. Okay, now we are given 25 milliampere in a resistance of 5 ohm. Find the suitable resistance to convert into. So it's a galvanometer which can bear 25 milliampere and a resistance of 5 ohm. We have to find suitable resistance. That means suitable resistance means shunt or value of shunt. That means the resistance to convert into an ammeter of range 0 to 10 ampere. Okay, we are given 0 to 10 ampere ammeter right there. Ammeter maximum value and minimum value, and voltmeter reference 0 to 2 volt. Okay, let us solve this. So solution, we are given Ig, that is the maximum value of voltmeter, which can call full deflection in voltmeter, that is 25 milliampere. So we have to convert that milliampere into ampere. So you have to know that the conversion of those, that means 1 milliampere is equal to 10 to the power minus 3 ampere. 1 microampere is equal to 10 to the power minus 6 ampere. 1 megampere is equal to 10 to the power 6 ampere. So now we have to compare 25 into milliampere equal to into 10 to the power minus 3 ampere, which is okay, and resistance is given 5 ohm. So resistance is given 5 ohm. Then we have to find I is equal to maximum current that emitter can measure equal to 10 ampere. We have to find the value of shunt, that is resistance. Okay, and then we know that formula of resistance S is called, what the formula, do you remember? S, that is Ig, that can be current that can catch full scale deflection in maximum current that can pass through galvanometer, and resistance of galvanometer all upon maximum current that can be measured by ammeter subtracted by the current passes through voltmeter. So let us put those values. 25 into 10 to the power minus 3 into 5 all upon 10 minus 25 into 10 to the power minus 3. So after calculating all these values, we got 0.125 ohm. So that is the resistance. So we have to write the conclusion. So thus we can convert the galvanometer into ammeter of range 0 to 10 ampere by connecting a shunt of 0.125 okay, mistaken, 0.125 ohm in parallel to the coil. Okay, and let us look at the second question, that is an voltmeter of range 0 to V voltage. So in the similar case, Ig is equal to 25 into 10 to the power minus 3 ampere, is equal to 5 ohm, B is equal to 2 voltage, Rs, that is the resistance of shunt, is equal to watt. So we'll do the derivation later, but I'll do the derivation of converting a galvanometer into voltmeter. So remember the formula, R is equal to V by Ig minus G, and put those values, that is 25 into 10 to the power minus 3 minus 5, and it gives the value of 75 ohm. So right conclusion, that's it. Let us look at the words. If you need a screenshot, you can take a screenshot. So that's all for today. Do share, like and subscribe.